I would have asked anybody has heard of carrying capacity. I'm sure this is not the first time you're hearing this word. You've heard it before, you've interacted with it before, maybe even in other. But today we are going to look at it a little bit in depth, and we are going to make our discussions around it. Even our class discussions, they're going to revolve around carrying capacity. And we're not just looking at animals. I know many times when you're doing carrying capacity, we tend to look at animals, but we're also going to look at human beings. And their carrying capacity, and whether carrying capacity applies to human beings or not. So before we get into carrying capacity and everything in it, I want us all, first of all, to think about something we call logistic growth. Logistic growth. Now, most populations cannot continue to grow forever. So there will be a time where they will, and we realize that the limitations will actually come from the resources that these populations depend on to thrive or to grow. Okay? So, in short, you're saying, in most cases, as long as the resources are there, populations continue to grow. But these resources start getting limited, then it directly impacts the population. Population growth happens when the population growth rate decreases, increases. I want you to note that decreases. I want to note this word, increases. What is decreasing? It is the growth that will decrease. When does that happen? Population continues. So right now, if you're still wondering, what does this mean? Just a little patient, we are going to find out what that means. So that was just a preamble in introducing the issue of carrying capacity, because carrying capacity, populations and resources. Okay, populations and resources, populations and resources. So just a loose definition of carrying capacity is the it would use the word maximum. But in this one, we're just looking at the largest population that can be supported infinitely available in the environment. This word that can be supported indefinitely would also be used like the word sustainably over a long time, a time that you can't say is 10 years, 5 years, that kind of thing. So carrying capacity is the largest population or the maximum population that can be supported indefinitely or sustainably within the resources available in the, when we're talking species. So that is very good to note right from the word go. Why? Because water comes in the environment needs so much, and an ant would need so little. So the carrying capacity for the land for those two species cannot be the same. So that's another important thing to note. the issue of spatial. Logistic growth assumes that essentially until an upper limit or carrying capacity growth rate slows down and stops. This is characterized by an S-shaped curve. S-shaped curve in 301. Remember when we were culturing life, when we were talking about culture of life feeds, the phytoplankton and the zooplankton, and we talked about the S-shaped curves, whereby at the beginning there's the lag phase, but not in number. And then from there, slowly we got into the X phase where there was huge growth. And we said this was the right time to harvest. And then to start death rate. Okay, and then of course after that it's just a downward spiral. The curve goes down, it points downward. This is called the S-shaped curve. It's a growth curve, but it's not the only growth curve or the sigmoid curve. Logistic models are density dependent, where the growth rate is equal to the birth rate minus the death rate. Growth rate in a logistic model, the growth rate is equal to the birth rate. So growth is the same as the birth rate, but you rate. Come across it, I think more. So when you say that the population is below carrying capacity, yes, that this population has the potential to increase. Why? Because the resources are still there. Remember what we said is the limit? It's the resources. So when you look at a population and see, oh, it's not yet at carrying capacity, then you're saying there's a potential to increase if the resources are there. While if a population is above the carrying capacity, then what do we expect? We expect that it is going to decrease because the resources that it needs to keep growing are already limited. They are limited already. So we can expect nothing else apart from a decline. Now, the factor that keeps size at equilibrium is known as the regulating factor. Let me take you back to the culture of phytoplankton and zooplankton. I don't know whether you remember when we were talking about the culture of these life feeds, we kept saying that after you harvest your first batch, you have to keep adding whatever is limiting. If it's you need to add it. If it's to improve it, what is it that is limiting? And this is what we are calling the regulating factor. What regulates it? So if you want to continually harvest this phytoplankton, you have to know what is your regulating factor and act on it. Population size decreases above carrying capacity due to a range of factors depending on the species. It could be due to maybe you are trying to grow. And remember, when I'm talking about phyto and zooplankton, this is not just limited to them. It includes all the other species. So your population, the size may decrease. It will decrease when it goes above carrying capacity because obvious, the space already is limited. There's not enough space. There is food supply that is limited. Maybe there's also sunlight which is limited. Maybe others have grown tall. Can't get enough food supply. There's competition. There's not sufficient space. Then you expect that there is going to be a decline. Sorry. Now, the carrying capacity of an environment may vary for different species and may time. I think I already said this. It may change over time, especially when you look at seasons. With different seasons having different environmental variables. For example, there may be a season where there's a lot of rain, so you even have, look at the plants, you have so many plants sprouting and growing very fast. But once the rains, you only have, many of the plants cannot sustain because some of the things they needed for their growth are already limited. For example, water. So what happens? The carrying capacity of an ecosystem, so depends on 3 factors. If you are looking at ecosystems, if you are assessing them for their factors to of resources available in that ecosystem. Okay, for example, if it's cows, you want the carrying capacity of paddock within a pasture. So you're going to look at what are the available resources? Is there grass enough maybe to feed 10 cows for a month or for a week that have good nutrition? Is there water? Is there shade? You know, all those things are available in that ecosystem. You have to look at them, you have to assess them, you have to take an inventory of them. The second thing, of course, you're going to look at the size of the population. How many cows do you want to put in that paddock, for example? How many cows do you want to put in that